Welcome, everyone, to Debate Me Brah, the show where we ask interlocutors to step into the ring and defend their point of view. On tonight's debate, the mercy seat, exactly, the curious girdle. On tonight's debate, we are asking the question, is the Big Bang scientific? And we have both Leophilius and Church of Entropy here to help us find an answer. So with that, it's time to debate me, brah. Ooh. Hello.
All right, thanks guys for showing up. Thanks for coming to the debate.
Sending love out there on the inner tubes. And if you're feeling fancy, feel free to like, follow, or subscribe. And don't forget to set that button to all so you can join our premieres and be on our live streams. And this debate is sponsored by our Patreons, including KO Champ, Oz from the Atheist Roundtable, Ian Davenport, Grumpy Old Cuss, Diana Smith, Pat Lowinger, Dale Pastel, Dave Gar, Scott Duke, and Regos. Woohoo!
Thank you, guys.
And you can help us make even more content at our Patreon page at patreon.com/Amy Newman.
Apparently, we're also sponsored by Moonlight.
And Moonlight. Did you want to look outside? And along with my co-host, James W., we will be tonight's moderators. Our job is making sure, these two wonderful debaters don't talk over each other, though we don't mind if things get a little spicy. Speaking of spicy,
little saucy.
Little saucy. Tonight's debate topic is the Big Bang scientific, with Leophilius taking the positive and Church of Entropy taking the negative. We will also have a Q&A section at the end of the debate, so if you have a question for either debater or both, feel free to tag me in chat at AB Newman. With that, I'm going to hand it over to our first interlocutor to introduce themselves and then give their opening statement. And with that, Leophilius, the floor is all yours.
10-minute opening.
Thank you. I don't know if I'll need all 10 minutes. I'm probably not going to introduce who I am. If you're interested, just check out any links that are provided in the description of this video, if they are provided. The question of tonight's debate, discussion, whatever you want to call it, is the Big Bang scientific? I do think this is an important question, considering that the Big Bang is one of those scientific theories that has, for at least a part of its history in certain circles, been mired in controversy and doubt. But before we really dive into answering that question, the first thing we need to do is define what it means for something to be scientific. Something can be scientific in a number of particular ways, so we're going to have to examine what those are and figure out which ones the Big Bang fits. Something can be scientific in the sense that it is a scientific hypothesis. It is something that is proposed as some explanation of something that we observe about the physical world around us, but hasn't yet been confirmed as in experiments as actively explaining that in reality and giving us a mechanism for it. Or we could talk about something being scientific in the sense that it has met that threshold and has thusly moved from hypothesis to theory, that it is something that has met all of the tests that we need to do, that has passed all the experiments that we have done, and tells us how things happen in reality. It makes predictions that we have verified, and I would argue, as I'm going to in this debate, that the Big Bang has met that threshold, that it is a scientific theory. So what do we have that indicates that the Big Bang is in fact scientific? The first piece of evidence, and what I would argue is the strongest piece of evidence, is what is often referred to as the cosmic microwave background. This is a background radiation of electromagnetic radiation of photons, low energy photons, that permeates all of space-time near uniformly, and at a near uniform temperature. The reason that this is very, very powerful evidence for the Big Bang is that there are very few ways to recreate. In fact, there aren't really any ways to recreate our universe with such a thermal, a black body background radiation without that universe having started in an initially very hot and very dense state. The reason for that is because in such a state, electromagnetic radiation will couple to matter. It will consistently scatter off of matter and will not be capable of traveling or free streaming through the vacuum of space. And due to this, you don't have radiation moving anywhere. But if a universe that is expanding on the average over its history and thereby is cooling down, at some point you would expect that that electromagnetic radiation would decouple from the matter and would begin to free stream through the vacuum of space, and that we would be able to detect that radiation today. And we have. That's exactly what the cosmic microwave background is. It is most literally the afterglow from the Big Bang. It is, I would argue, effectively proof that the universe was very early in its history in a very hot and very dense state where electromagnetic radiation was coupled to matter. And that is such a condition that we would expect something like that to occur in. So how do we know that the universe is expanding? Well, the primary piece of evidence for that is the observation that Edwin Hubble made called galactic redshift, that galaxies, the further away they are from us, the redder they appear. And this doesn't seem to be a result of the galaxies moving because the redness, so to speak, is directly proportionate to their distance. This seems to indicate that the electromagnetic radiation, the light being emitted from these distant galaxies, is being stretched as it gets here, and thus the further away a galaxy is, the more that the wavelengths of light coming from it have been stretched, and that should be proportionate to the distance of that galaxy if the universe, if space-time itself, if the space between us and the galaxies is growing, and thus the observation confirms that space-time is expanding. Already, it seems that we have a very clear picture of, at least a rudimentary picture of the evolution of our universe. The third piece of evidence I'd like to bring up is the Friedmann solutions to Einstein's field equations. Einstein's field equations are a set of 10 coupled nonlinear partial differential equations which describe how massive objects behave in a space-time that can be stressed by the presence of mass or energy. No need to get into the details of those equations. All I'm going to say is that the Friedmann solutions are a set of exact solutions to those equations that describe a universe with a near uniform distribution of matter and energy, such as ours. And under such solutions, space-time is expanding. This is why Albert Einstein had to include his fudge factor, if you've ever heard of it, into his equations, the cosmological constant, to make space-time remain static, because that was what the consensus was at the time. We now know, because of Edwin Hubble and George Lemaitre, that that is not the case. Space-time is indeed expanding, which confirms the Friedmann solutions to Einstein's field equations, and it also helps confirm why the CMB is observed. So this all is powerful evidence of the Big Bang Theory. Now, the thing is, the Big Bang Theory, and this is a very, very crucial point that needs to be made, because it's a point that I think is often missed on a lot of people, is that the Big Bang does not make any statements about the earliest moments of the absolute earliest moments of the universe's evolution, or the origin of the universe. All the hot Big Bang Theory tells us is that the universe, at some point in its past, was in a very hot, very dense state. It doesn't say anything about where that came from, why it came from there, or how. That is not what the Big Bang does. Secondly, we don't really use we still use the Big Bang Theory naturally, but it's not called that anymore because we've added so much to it. The standard model of cosmology, often referred to as the concordance model, is what's called the lambda CDM model. Lambda represents Einstein's famous cosmological constant, which was in fact reintroduced to account for the energy intrinsic to space-time that results in its accelerated expansion. And CDM stands for cold, dark matter, which accounts for the extra mass and the extra gravity that we observe in galaxies and in massive galactic structures and superstructures that we've dubbed observed thus far, dark matter. This is the concordance model. It doesn't make, much like the theory of evolution in biology makes no statements about how life originated. It just tells us what life did from very, very early points after its origination to now. The Big Bang Theory, the lambda CDM, the concordance model does not tell us about the origin of the universe. It only tells us what happened as the universe evolved from about 10 to the negative 32nd seconds from onward after t equals 0. That's all it says. So the Big Bang is not a model of the origin of the universe. It's a model of how the universe has evolved from just shortly after, potentially, depending on how far back we can actually go, because we don't know that yet. It just tells us about what the universe was like very early on in its history up to now. And the model states that the universe was once very, very hot and very, very dense, as all mass energy was compressed into a very, very, very small volume. And from there, space-time expanded, carrying all of this with it, and cooled down such that radiation, electromagnetic radiation decoupled from matter, and large-scale structure due to general relativity and gravity began to form out of the material that permeated the whole of space-time reality at that point. And this is exactly what we observed. We have also observed that the abundance of hydrogen, I think the universe is still something like 70% hydrogen in terms of all baryonic mass. I might be wrong on that, but I think I heard it's 70% hydrogen still. The abundance of hydrogen is also explained by the Big Bang model. And this isn't even accounting for inflationary theory and all of the four main absolute primary observations that need to be explained by it, that all have been explained by it, that also give that the universe was in a very, very hot, very, very we're not really talking about inflationary theory, although I would argue it is relevant to some degree. We're talking about the Big Bang, and I would argue thusly that the Big Bang is indeed scientific. It was a hypothesis that was proposed. We derived logical conclusions from it. We tested reality with experiments to see if those conclusions, if we can observe them, to see if it has explicative power, if it can explain why we're looking at things the way that they are. And the fact of the matter is that it has met every single one of those tests. There were things that it couldn't explain that it now can. It has met every test that's been thrown at it. It is indicated and hinted by all of the physics we have surrounding cosmology and physics on the large scale. So I would argue, yes, the Big Bang, though some might not like it, is indeed scientific.
Thank you, Leo.
Thank you so much, Leophilius. And with that, we're going to hand it over to Church of Entropy so she can introduce herself and then give her opening statement. The floor is all yours.
Hi, Amy, James, Leophilius. Thank you, everyone, for being here today. I'm just about to share my screen, if that's all right. I've got slides ready to go here.
Yeah.
Appreciate being welcomed on this channel today and for a chance to defend my position. Is it up there? All right, looks great.
Yes, ma'am.
It's up.
All right, so the Oxford languages. Anyway, sorry, not to jump right into it too quick or anything, but yeah, I'm Jen. Church of Entropy, got a blog and a YouTube channel, and talk about science and consciousness and theology, philosophy, whatever else strikes our fancy. I'll jump into my defense against the Big Bang being scientific. Oxford Languages defines science as the pursuit and application of knowledge and understanding of the natural and social world following a systematic methodology based on evidence. You see here I have a list. Basically, what it takes to make it as science, but at the end of the day, essentially, science is about models that make predictions. So the first thing we want to look at when we're talking about the Big Bang is what it consists of. So some people will try to say that it doesn't actually include a singularity. So there's a lot of apologetics. We've even seen some of it in the opening of my opponent here of like, well, it doesn't actually say anything about the beginning. It's just, 1 10 to the negative 32nd second after, and that's supposed to somehow fix this issue. So we want to talk about, first of all, what is the point of a singularity? So in math, we have to define singularities sometimes because we are preserving symmetries elsewhere. So for example, the function y equals 1 over x necessitates a singularity at 0 because the function is going to be approaching from the positive and negative directions to different limits. One's going to positive infinity, one's going to negative infinity. So the math just invokes, well, it's singularity at 0, aka it's undefined. It doesn't make the function any less of a function. It's just not defined at that point. Same thing with the imaginary number. You could say, well, what's the point of the imaginary number? Well, it's it's part of the eigenvectors of the rotation matrix. And since we need to be able to invert rotational matrices for computational simplicity, we need the I there. We're not saying that it's more real than that. It's just real enough to resolve this symmetry issue that we encounter in coordinate systems, necessitating the invention of the I equals the square root of -1. But physics, on the other hand, is intended to describe the physical reality. A singularity in physics refers to a point where the laws of normal space-time break down. Any use of mathematics and physics ought to be grounded in genuine need, and we must question the scientific basis for the assertion of a singularity in physics in the first place. Why should the laws of physics break down? If they could break down, are they truly laws? The answer is, of course, a resounding no. Moving right along. So here we've got this presumption of the model, just to bring some attention to the fact that a lot of stuff in science isn't really grounded in observation. For example, the particle model. There's no real good evidence that particles exist. If you look at even the most simple atomic systems, this doesn't look like particles at all. It's the hydrogen electron orbitals. It's a basic, very fundamental thing, yet look how non-particle-ish it is. It is really quite waveform-ish at the end of the day. So why do we assert that there are particles in the first place? We're not sure. Why is there a Big Bang, a singularity at the beginning of the universe? We're not sure. Well, the answer is that they're just really not scientific ideas. So Big Bang is the prevailing cosmological model explaining the existence of the observable universe from the earliest known periods through its subsequent large-scale evolution. So basically, it's the model that is, as my opponent said, it's used to infer, based on the fact that the universe is expanding today, to infer that at some prior time it was minimally expanded, i.e. maximally dense. And that would be an error, because we clearly have expansion in thermodynamics without having to invoke any type of singularity. So I think we could plod through this mystery without ever having to assert, for no real reason or no good enough reason, that the laws of physics can somehow break down. So I'm not going to read the entire definition, but I'm pretty sure people are familiar with this idea by now. Here's your standard diagram that's quite popular. Historically, it came about from a Catholic priest educated by Jesuits named Georges Lemaitre, who first presented an allegedly scientific model in 1932, suggesting the universe came from a primeval atom that disintegrated in an explosion. So very simplistic thinking, not making any predictions at all that can be verified. It's not the same thing to reverse engineer your results to match the theory as it is to have the theory actually predict a result. So you have to remember that in science, you have to be careful not to do this tendency of wishful thinking. What's the best evidence against the Big Bang? Well, it's clearly the Pauli exclusion principle. There's a hard limit to the maximum density of matter in the universe. That's been instantiated over and over and over again. We can't get to more than 118 elements because why? Maximum density. It's reached the 3+1 measurement limit. We can't have more than 2 electrons in the s orbital. Why? Well, Pauli exclusion principle. That applies to all, not just electrons, but all fermions. So this can't be true if the Big Bang is true, because the conditions during the Big Bang would have been more dense. So that's why they have to say that it's a singularity, because what we observe now doesn't match up with it. I'm not the first person to state issues with the Big Bang theory. As my opponent has already conceded, there have been issues with this since its inception, but it really just boils down to the fact that science is predicated on causality. No matter what anyone wants to say, science involves cause and effect. You speculate the cause as a model. You get to then infer a predicted result and then figure out if it matches. Big Bang doesn't rise to that level. Same with evolution, incidentally. That's just a descriptive model. So that's very interesting that he brought up evolution as well. So really just talking about a simplistic model. How astronomers explain the way the universe began. That's saying that on NASA, but it's actually not the beginning of the universe. It's just how it began. So this seems very dishonest way of arguing. I'm going to now show that you can easily predict the effects that allegedly require Big Bang without a Big Bang. So what are our major things? The CMB. Well, if you look up at something called, I forget his name. It was some type of Hawking radiation. There you go. He predicted a similar effect. So the cosmic microwave background is a similar effect as this type of Hawking radiation. So we have a canonical conjugation relation between position and momentum, which means that if two waveforms are super close, the delta, the difference in their momentum will be very different. And so you think of it as like if things get really close together, their momenta are super different. That gives them the energy to break apart. And that's essentially where you get fission, alpha decay, neutron emission. And the closer they are together, the more energy can be used to break them apart. So the lowest energy is photonic emission, and then the supremely 0 point lowest energy emission would be your cosmic microwave background. It's a non-zero 0 point energy, not a residual from some magical explosion. Can someone please explain to me why the dark matter map is the same as the CMB map? Self-referential much? How do we have the other two tough to predict things, which are redshifting, not just redshifting, but the farther something is away from us, the faster it's going. That's not predicted by Big Bang at all. Also, faster than light recession speed, that would appear to mean that something to do with coordinate systems in general relativity that were not in the uniform coordinate system, which seemed to be suggested by Big Bang since it was one event alone. But if you use this standard exclusion model where you have a maximum density, you have a model to create new stars and generate new space in the meantime, which means that each time you create new space, there'll be creative velocity, which will lead to additional velocities, temporal lensing across various created stars farther away, more velocities added. That's what explains it. Big Bang can't predict why there are 100 nearby galaxies that are blue shifted, but my model predicts that no problem. In the close proximity, it would just be randomized velocity, but as you get farther, there's more space. The net velocity vector is moving away. All right, so I think I'm coming to the end of all my time here, and I guess let's just check here. How much time?
Right there.
Am I right there? Okay, well, I didn't
seconds,
quite get to everything, but suffice it to say, I could say a lot more, and thanks everyone for listening to my opener. Talk to you soon.
So we'll kick it back to Leo for a 5-minute response.
Yes, in fact, that's go. Thank you so very much, Leophilius, for your opening statement. No, thank you so very much, Church of Entropy. See, I tore my brain up. With those flagpoles set down, I'm going to hand it over to Leophilius, and thank you so very much, Church of Entropy. But time to hand it back over for your 5-minute rebuttal.
Thank you. Yeah, that was quite a lot. I've got quite a few points to respond to here. So the first thing is Jen said that, ultimately science is about models that make predictions. I agree with that wholeheartedly. I think that that's really the endeavor of science, at least contemporarily, is to make models. And we make models to try to explain the things that we see in reality. And the models that make predictions are really good models. But what's even better than that are the models that make predictions that can be confirmed, that we can confirm and have confirmed in reality. And what we call those are scientific theories. These are essentially models that make predictions that have had the predictions that they've made confirmed largely such that they actually make explanations about the observations that we see in reality, and so we call those theories. And that is ultimately what the Big Bang is. She also mentioned singularities. The Big Bang initially predicted a singularity because of general relativity and the fact that at a certain point, the functions within general relativity tend toward infinity, i.e. they become singularities. As Jen said, these are mathematical objects. They are not actually physical objects that exist in reality. Nothing is actually in a singularity. When we get singularities, what this ultimately means is that the physics that we're using to describe the system cannot be carried past this particular point in describing or explicating what the system can do or is doing without some form of modification. And this is what we would call a quantum theory of gravity, which we don't yet have. If you go to any institution and ask any astrophysicist or cosmology whether there is a literal point of infinite density in zero volume, they'd say no. We just don't know what's happening at the earliest moments of our universe. Our current models can't predict it. Now, particles do exist, but they're not entirely relevant to the discussion. I just want to mention briefly that we have quantum field theory, and we know that what particles are essentially localized perturbations in these fields that are above what the general expectation value of the field is. But that's not entirely relevant to the discussion, so I'm not going to really explicate it any further. Same goes for the Pauli exclusion principle. This doesn't really relate to early universe cosmology, and it doesn't relate entirely, at least not in any large scale way, to quantum gravity research, which is what we're utilizing to take us beyond the Big Bang, so to speak. It'd really be beyond inflation, because inflation precedes the Big Bang, which is why we know that the Big Bang isn't the beginning of the universe and doesn't make any statements about it, as I initially stated. There were issues rather with the Big Bang, but they've largely been resolved re the lambda CDM model that I mentioned earlier, which includes cosmological constant for the acceleration of space-time, which I would like to mention briefly that faster than light applies to things in space-time where they're not allowed to do it, but not to space-time itself, where over sufficient enough distances, objects would be observed to be moving away from us faster because there's so much space between us and them that there's just a large rate of expansion. But the inability of something to travel FTL or at superluminal speeds faster than light applies to things in space-time, because it's a property of space-time on things in it, but it isn't a property to space-time itself as it's expanding, which is just a metric expansion of its scale. There's no physical object getting larger. But so incorporating all of these things, cosmological constant, cold dark matter, inflationary theory, almost all of the current issues with the Big Bang, other than it isn't a complete description of the origin of the universe, that's really the only problem with it, have largely been resolved. So pointing out problems with the Big Bang, or the way that the earliest people who developed it spoke about it, doesn't really do anything for how we understand it today. Models are a great thing. And models which are descriptive and accurate, and very accurate in their descriptions, are good models. She mentioned models that are descriptive. If they're accurate in their descriptions, if they make predictions that we have confirmed, that's science. They're scientific, and that's exactly what the Big Bang is. She said that she had a model, and her model makes predictions, but I didn't really hear much in the way of a model. I just kind of heard assertions about that this is what happens, but I didn't hear anything about this is how it happens, or any confirmed predictions that have been made by the model, such as all those that have been made by the Big Bang, which many things like the CMB, the expansion of space-time, the abundance of hydrogen, the cosmic microwave background, are all predicted by the idea that the universe started in a very hot, very dense state, was expanding on the average over its history, and evolved from that point. And that's exactly what we observed. There's no reason to doubt or reject the Big Bang as being scientific. And I don't think that if anybody talked to professionals or any individual well versed in these subjects, that they would agree with such an idea.
Thank you, Leo.
Woohoo! Thank you so very much, Leophilius, for your rebuttal. And with that, we're going to hand it over to Jen for her 5-minute rebuttal.
Awesome. Yeah, thanks. I didn't get a chance to get to all my points and show how it's a model that makes predictions. It predicts the results we already see, and there's no need to invoke a singularity. Singularity would be a violation of the least action principle, which is a principle of physics law, never been observed to be not operating. We should always be very suspicious when people expect us to suspend our disbelief for things that are required for belief, things like causality. So I think it's just to address some of the points that to state it like the universe was created or that it's possible to model the creation of the universe is to phrase it wrong, because we have no evidentiary basis to believe that the universe is created at all. The fact that mass exists and the fact that we have observed conservation of mass here suggests that the mass is eternal, as there is no mechanism to cause it. A 0-point energy, which is the lowest possible energy of a system, we have tons of evidence of systems with a non-zero 0-point energy. So observing a non-zero CMB value is predicted if you understand already that the 0-point energy of all other systems that we've ever found is non-zero. That's just an attribute of matter. The fact that fudge factors need to be invoked at all, as was mentioned, is another big red flag. The assumptions of Friedman's thesis are uniformity and isotropy. So I find it very curious that these assumptions allegedly match what we observe, and yet we're expected to believe that a situation completely different from that, where it wouldn't have been uniform or isotropic, would be somehow consistent with this eventual situation. So totally crazy, explosive, bang, 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 non-uniform situation leading to total uniformity. How about it was just always really uniform, and it has a mechanism for expansion, but it also has a mechanism for compression. Cyclical universe, definitely going to be more matching up with what we observe, and we don't have to stop the thought process at some mystical big bang that is impossible to speculate anything past. Well, we don't really know what it really was and how it really came to you. We just know that because it's expanding now, it must have been super dense long time ago. This is kindergarten tier reasoning. So it seems really weird the way general relativity is sort of peppering in this discussion. It's not even clear to me if it predicts a singularity or if it's being used to justify this singularity. My opponent defined particles as localized perturbations in fields without defining localized perturbation or field. A very concerning thing. Do you have evidence that perturbations in fields exist? Do you have evidence that fields exist? Aren't fields predicated on the real number line, which can be proven not to exist by the Pauli exclusion principle and quantum uncertainty, Heisenberg uncertainty principle? How much time do I have left?
You have about 2 minutes.
Thank you. You said there was no reason to reject the Big Bang as scientific, whereas I just see it as there's no reason to accept that there would be any interruption to the laws of physics. And if our results are telling us that the laws of physics break down, what we should be taking from that is that we just haven't understood the laws on a fundamental enough level to get them so that they don't break down, because that's what a law is. We either live in a universe of laws or we don't, and these laws are what we're supposed to be inferring through science. And since science is the thing, it's pretty clear we live in a universe that involves causality, and the causality of the universe is the reason we can understand it with science. Even when our models are not dead on, they can make some predictions because we live in a fundamentally logical universe. That is the rule, not the exception. All right, so the Pauli exclusion principle, I don't know why you would ever think that that could break down, because it's very universal and it applies on multiple levels. It's something that could be demonstrated in slit experiments, chemistry, nuclear physics. So I just want to say that I think it's really clear that the people touting Big Bang really don't have answers for the overall aesthetics of the universe, nor are they going to give any insights, unlike my model, which predicted the creation of stars in the center of galaxies and was later observed, which I have the link that I could share at any time to show that the model actually does make predictions and they can be verified, and they weren't verified prior. And that's why the article says for the first time, and this was in 2017. So you're welcome for correcting that, and it would be nice if that model could be acknowledged as actually being scientific and making predictions, because this sort of gaslighting of people pretending or actually not understanding what science is, maybe it's time to learn. Model, The model has to meet Occam's razor, aka be as simple as possible, aka not have to invoke magical thinking to justify the conditions of the Big Bang with a bunch of mathemagic that nobody really, don't even try to tell me you understand this general relativity stuff. Nobody understands that stuff because you can't explain nonsense. Thank you so much, and I'll see the rest of my time.
Woohoo!
40-minute open discussion period.
And all right, folks, all of our chips are now on the table. Thus, we're going to move into 40 minutes of open discussion. Ladies and gentlemen, the floor is all yours.
I have a quick question. Do you know what a white dwarf is?
It's a type of star, I imagine.
Yes.
Did you know
do you
that
know
all of
how white
the-
dwarfs are generally sustained?
Did you know that all of the planets in our solar system are observed to be the same age to within a very small error margin? How does expansion
Yes,
and
I
accretion
did.
predict this? Doesn't that
well,
imply that all of the planets were formed in the same event? Your model does not
Yeah,
predict this.
I can get to that. I was trying to go down a line of questioning. Do you know how white dwarf stars are sustained?
Let's not go into various random stuff, but I'll grant
I'm
you,
not.
it's not
I'm
all wrong.
getting to a
I
broader
want to know
point.
how are you gonna link this to the Big Bang is what I want to know, because I don't want to end up in the weeds like I did the last time I debated an atheist thing.
I wasn't. You had made a statement about something that somehow shows that the Big Bang isn't scientific, and I'm trying to get to how that point doesn't work.
Well, then
it's
you don't need to
a
invoke
Socratic
stars
method
for
of
that.
asking you questions.
Yeah, and
Well,
I'm
actually, I
tired
do.
of
If
being
you would
gaslit by the
allow me
Socratic
to-
method. That only works if you have
if you
perfect
would allow
knowledge.
me
The
to,
Socratic
I mean,
method
if you
is
just answer
limited
the
to your own
questions, we could
knowledge
get there.
basis.
And guys,
Just go to the end of it. Just skip to the last step where I have to accept some garbage.
Well, I'm trying to gauge how much you understand about the subject, because it's going to help me understand what particular direction I'm going to need to take in this discussion. So if
Assume I'm
if you
familiar
if
with
you,
the general
if,
classes of stars.
if you please, then you should know the answer to this question. What sustains a white dwarf from collapsing in on itself further?
I am not going to speculate about that.
Electron degeneracy pressure. Do you know what
That's
gives rise
wonderful.
to electron degeneracy pressure? It's actually something you mentioned.
Is it the Pauli exclusion principle?
Yes, it is the Pauli exclusion principle. You said that can't be violated or it can't break down. So this idea of a singularity, which it can, and this is what's called the Chandrasekhar limit, which is named after the Indian-American physicist Subramanian Chandrasekhar, who showed that white dwarfs that are accreting matter can reach a critical mass, which is 1.4 solar masses, at which point electron degeneracy pressure, the Pauli exclusion principle, is not capable of sustaining that object under its own gravity. Gravity can overcome the Pauli exclusion principle. It can break down, so to speak. But the broader point here is that the concordance model doesn't really predict a singularity. It's not saying that there is some physical object called a singularity. No, it doesn't. Then what's
why
the
does
point?
It have to invoke
What's
one?
the point of quantum
so
gravity?
That it can cheat, so that it can.
What's the point of quantum?
The point of quantum gravity is to unify, and if you
It's to
understood
go
it, you
beyond
would
the
realize
singularity.
my model is actually a quantum gravity
do.
model. Please don't cut me off. My model is a quantum gravity
Okay.
model. It predicts everything. Quantized gravity. Mass is quantized, gravity isn't. It's all very simple, and it doesn't require you to invoke a point in history when everything was just this uniform mush that exploded. Did you know that they've observed a star based on a emission spectroscopy that is older than the age of the universe?
An explosion.
Did you know that?
No,
they've
it's
dated
actually
a
not. It's
star
the
to
Methuselah
14
star, and I'm
billion
not
years.
actually. I don't actually yet. Obviously, I knew what it was because I knew the name of it. I can't remember exactly the reasons why it's not accurate, but it has to do with statistical anomalies and how measuring the star. It's not actually really older than the universe. That wouldn't be possible.
Does that sound like an excuse to you? Not that you're making the excuse, but that the scientists are making
No.
the excuse. Because it seems to me that if we're dating
No.
something at 14 billion years, but our calculations say the universe is 13.77 billion years, and it started then, and we're getting measurements. Like, doesn't it seem weird that there were stars pretty much present since the beginning of the universe, since it was allegedly so hot and mixed up and blah, 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 blah. That's what was happening. It all broke down. Can't you see it's magic? The laws of physics aren't laws. I can break them with math. Do you really
Okay,
think
so
that you can
yeah,
slip a
everything just
singularity
cut
into
out for me
science
for
and that
like
no one's
10
going to notice?
seconds.
Oh, well, welcome back.
But
It's okay.
like I
You didn't-
said, the Methuselah star is not actually older than or as old as the universe.
Says you, but it's dated as being
Well, no,
older.
says the scientists. They
750
said that
million years older.
utilizing traditional methods, this star appears to be older than the universe. But and I can't remember off the top of my head why it's not, but I know it's not because the professionals are saying it. And given that I'm not a
Oh.
professional, I can trust their word.
Well, shouldn't you be trusting your own judgment of logical assertions so that you don't end up in a situation
How
like
can
this?
I trust my judgment on something I don't understand well enough to be able to accurately make judgments on?
Well, you can go with your best guess, as in, does it make sense that the laws of physics could break down? Well, if they can break down, are they laws? No. So that doesn't make sense. So anything involving a singularity is just
Wait,
not under the domain. It's not under the purview of science.
What do you think is meant when we say so, like a physical law or a scientific law? What do you think is meant by that?
It is a symbolic representation of one of the facets of the causality of the universe, which, if correctly asserted,
classical
will
level,
make
yeah, that's-
predictions.
Yeah, at the classical level, that's
What it's
certainly
supposed to
accurate.
be. And then, but people came in and tried to change that just a tweak, and
Who?
it's like you can't
Who
change
tried
it
to
because it
change
breaks down. Well, it's been going on since the advent of quantum mechanics. You made several arguments to me. You said there are acausal events like nuclear decay. You're going to tell me
No,
that's not
there are.
caused by something?
Well, no, it's not caused
That's
by.
absurd.
But see, that there is a that's not really relevant to the discussion of whether the Big Bang is scientific. I think I've prevented.
It has to do with what is science. Science is about causality. Therefore, you're axiomatizing
What do you?
causality
I don't know
to
what
make
you
assertions
mean
of
by
science.
that. When you say science is
Causality
about
means cause
causality, I
and
don't know what
effect.
you mean. I know what
Causality-
causality means. I don't know
Yeah.
what you mean when you
So
say
there's
that
some
science is
causes,
about causality. I
there's
mean,
some
causality is a
causes,
part of
and then there's
science,
some
but it's not
effects.
fundamental
There's
to
some
it.
causes. It is fundamental, I'm afraid. There's some causes, and then there's some effects. You understand that? And science is the bridge between those things where you say, here's the model, and I'm going to try to go from my causes to my effects through some symbolism and math and diagrams and predict the effect. That's what science is. It's predicated on causality. People
Except
want to
that
come in and
our
say, well,
most-
actually, it's not predicated on causality. I'm afraid
It's
it is. It breaks
not.
down if you deaxiomate.
No,
you can
it
say that,
doesn't.
but you can't back it up with proof because
So-
any proof you assert is going to be based on causality.
Do you? Can you give me the Schrödinger equation, please?
Let's not do this, okay? Let's not go down that
Well,
road.
I'm wondering.
Why don't we stick to the actual
Why is it?
equation?
Why is it that it tells us that we can't actually determine what a physical system is doing until we measure it, which seems to violate this idea that we can't understand systems unless we're understanding it in terms of causality. How then do we understand as
The
well as we
observer
do
effect doesn't negate
stochastic
causality.
systems?
The observer
I
effect doesn't
didn't
negate
mention.
causality.
I didn't
You did,
mention
you-
the observer effect.
You're asserting the.
When did I say observer effect?
You said when we observe systems, it changes them. That's what the observer effect is. That doesn't negate causality. The observer effect is part of causality. It's a fact of the. It's part of the fact that we live in a proto-conscious or conscious
That's not
universe.
What the observer effect is. The observer effect states that we can't precisely determine what a system is doing until it interacts with some classical system.
So the fact that observing systems changes them is not the observer effect. Okay, then what is it?
Well, that's literally what I just said.
So
The
we
fact
agree.
that you can't determine what a system is doing precisely to any arbitrary precision until some classical system interacts with it. Yeah, that's the observer
Called the
effect.
observer effect, right?
Mhm.
So
Yeah,
I don't know that we're
I don't-
disagreeing here. So
yeah.
that doesn't
I'm
violate
wondering how
causality.
it's. I
It
never.
doesn't violate
I
causality.
never
That's
said
part of
that it
causality. So what is your
did.
point with invoking the observer effect?
Well, I never brought up the observer effect. It wasn't mentioned until you said observer
You
effect,
said
and now
that
we're here.
observing system. Okay, let's just drop it then. So Immutable Destiny has written the
So,
Schrödinger equation, or one of them, in the chat. Thank you. for the side dish there.
Yeah,
Appreciate
yes,
it.
I
You
did
got to
see
remember
that.
that math is not physics. Math is a language that we use to try to access the concepts of physics, but physics is just what's really happening. So you got to look around,
I
what's really
agree with that,
happening,
yes.
look up at the night sky, ask yourself, is there any chance in hell that that was one teeny tiny little crumpled up shit box of sometime in the past, or probably it just always looked more or less like it does right now? Which is more likely?
Well,
Just
when you
use
say
your
it,
own
when you
brain.
say it always looked more or less like it does now, do you mean being generally uniform?
What I mean is that it has a mechanism for contraction and a mechanism for expansion, and those two are in balance throughout the universe. So the distribution of matter is not always going to be the same, right? Your spatiotemporal distribution is going to be dotted differently depending on where things are in the matter cycle, but overall, yeah, you're just going to have this generalized distribution that won't change very much unless the universe is actually finite and it's actually possible for it to reach a maximum entropy state from which it can't recover any lower entropy states. But then you're basing that assumption on the universe not being infinite, and that's something we can't prove. We can't really prove the finitude or infinitude of the universe. We could just say, like, it appears to be infinite, but we'd have to be able to prove that.
Do you mean infinite and bound?
Precluded. Yeah, we're
You
just
mean
talking
infinite and
about
bound, correct?
physical
Okay.
size, just physical
So
size.
I did want to say that
or
on the
age.
largest scales, from like the earliest moments of the universe to now, the universe has remained roughly uniform. The only thing that's changed is, looking at the absolute largest scales, is the universe has gotten it on a margin so small it's almost non-significant, slightly more grainy. So the universe has remained roughly uniform and isotropic throughout its evolution at the largest scales.
So
It's only at the
see how
smaller
it's a bit
scales that we
weird?
see the clumpiness and stars and planets and people and things like that.
So don't you think it's a bit weird that they're saying, like, well, there's this time in the past when it really wasn't like this and there was a beginning? Like, to me, just the idea of a beginning of an infinite object makes no sense, because a beginning is something reserved to finite objects.
The Big Bang doesn't say that the universe had a beginning.
Well, then why does it say that on the NASA thing? Like, well, why do you keep trying to dodge that this is what the theory is understood to mean?
That's
like, it literally says that.
not-
It discusses, but you're saying it's 10 to the negative 32nd after the beginning of the universe, but it's
That's
not
correct.
describing the beginning of the universe. So it's 0.00032 zeros 1 second after the beginning, but it's not the beginning, and that's how you're getting out of the theory not really being scientific. Like, this is, and just, you actually brought up a good thing with evolution. Evolution has the exact same problem. That's why the people, when they criticize evolution as non-scientific, they're largely right, because it's not predictions, it's explanations. It's like, well, we've observed all these species and we're going to speculate as to how they turn into each other over time, right? Okay, and we think it's this. Well, does it actually that? Well, we don't really know, because we don't know how life arose in the first place. So yeah, there's something to be said for, what is really scientific, and it has to be truly a model that makes a prediction that is verifiable as not having been arising from some other cause, right? Like, you have to link it up correctly so that it
as is
always
true with
correlates.
both evolution and the Big Bang. And by the way,
Evolution
yeah,
doesn't
so
make predictions, and neither does the
from
Big
this
Bang.
isn't a discussion about evolution, and I've already listed at least 4 predictions that have been made by it and that have been confirmed. But before getting into that, from PhD theoretical astrophysicist Ethan Siegel, quote, "What happened prior to inflation, or whether inflation was eternal to the past, is still an open question. But one thing is for certain. The Big Bang is not the beginning of the universe," end quote. From Don Lincoln, who's a theoretical physicist at the Fermi National Accelerator Laboratory, quote, "Certainly the Big Bang expanded space and time, but remember that the theory of general relativity, along with all other known physics, doesn't apply before time equals 10 to the negative 43rd seconds," end quote.
Are you just going to filibuster here for the remainder of the time?
And from Sean Carroll, who's a theoretical astrophysicist and cosmologist at Caltech, said, quote, "My best guess is that the universe did not have a beginning," end quote. So the idea that the Big Bang predicts a beginning is not actually the consensus amongst contemporary cosmologists.
Shouldn't it also be predicting that this CMB should be diminishing over time?
It is. That's why it's microwave now. If we were to go back 10 billion years, it probably would have been much closer to ultraviolet. Maybe slightly below that.
before it was always microwave because it's an attribute of mass interacting with itself.
But it doesn't have any properties that would indicate that it's always been microwave radiation. And if it has been, given the time scales as well as the expansion of space-time, we shouldn't be capable of observing it at this
You're
current
assuming
time.
expansion. You're assuming
I'm assuming that because it's been
all these things in
observed.
Big
It's
Bang.
been observed.
Expansion's been observed.
Well, you don't.
So
The
has
expansion.
contraction. And so has
Well,
steady
when is
state.
the universe?
When is the universe
been
most
observed to
of
be
what is
contracting?
observed is steady state. Okay.
What do you wait? When has the universe been observed to be contracting?
Andromeda galaxy is blue shifted. Like, you should know this
Yeah,
stuff,
because it's moving toward us.
which is not predicted by the Big Bang, is it? We should all be moving
Well,
away from
because
all
it doesn't
the time.
deal really with the Big Bang. That deals with
So
galactic
now it just
cosmology
doesn't deal
or
with the Big
galactic
Bang when it's
astrophysics.
convenient. Stuff can
Well,
contradict the
wait,
Big
do you
Bang when
think
it's
that how
convenient.
galaxies form deals with the Big Bang, which makes statements about the earliest
According to
moments
you,
of the
it
universe?
does. According to you, the Big Bang does predict the formation of galaxies in like a couple minutes after
This
the
is like
beginning.
arguing that sociology is required to do evolutionary theory. No,
Well,
that's not
something's
the
missing.
case.
Something's missing for sure because you don't have any of the answers. You keep having
Answers
to
for
dodge.
what?
You're like, well, it's not actually about
What
the Big Bang.
observations have we made that aren't explained by the Big Bang?
Stars being formed in the middle of galaxies, for example, which
Well, but
proves stars can be formed. And my model predicts that. See, the thing is, my model predicts everything we
Big Bang
see,
cosmology.
plus
That's not
more.
early universe
So
cosmology,
shouldn't you adopt a model that makes all the predictions most simply, rather than having to invoke magical thinking of some beginning? Doesn't it concern you that you're using the essentially same metaphysics as the Christians? Have the Christians ever been right about science? I mean, they're the ones
What
arguing
does that
now
have to do with
creationism and
anything?
biology.
A Christian developed the Big Bang theory. I don't really
That does matter,
care.
I'm afraid. Well,
I
then,
don't
if you're
think it
being
does.
naive, and you're going to end up being tricked if you.
Well, how does
believe that there's-
naivety play into this?
Because the circumstances in which ideas arise has a lot to do with the ideas themselves, and if you don't acknowledge that, you're going to be blind to the reality that Big Bang is simply not scientific.
How so? I'm not understanding.
Because it is hinging on a singularity. Science is
No,
predicated on
no.
causality. Okay,
I
you're saying
don't
no. Do we
think
need to go to
that's
Wikipedia
true.
so that I can
Why-
then read
why
from
is it then-
Wikipedia to tell you that
why
it
is it-
necessitates a singularity?
Why is a singularity? The Big Bang originally didn't predict a singularity until general relativity was put into
So what's
the
wrong with an
equation.
uncreated universe model then?
Okay.
Tell me what's wrong with an uncreated universe model.
I
What's
know that
unscientific
everybody that
about
knows me in the chat is laughing their ass off
I
right
want to
now
know
because I'm a
you're so good at
naturalist and I have
science, because you're so
consistently.
good at science,
Do you want me to
allegedly,
answer
I
your
want to
question?
know scientifically what's wrong with an uncreated universe.
As I was trying to answer your question, I'm a naturalist. I believe that the universe is bounded at one end and exists tenselessly, that it is uncreated. The Big Bang does not make any statements about the earliest moments of the universe. That's not coming from me. That's coming from some of the most respected professionals in this field. So if your disagreement runs that deeply, then I would suggest you take it up with them. I am here to defend the concordance model. I am here to defend how the concordance model comports with the methodologies that we utilize in science. And I think that I have done a fair job at doing that. I don't, however, think that you have done a very sufficient job of showing me how the Big Bang doesn't make predictions when every prediction that it's made has been observed.
Notice how he dodged my question. Those aren't predictions, I'm afraid. Those are rationalizations.
Cosmic microwave background, expansion of space-time, the abundance of hydrogen.
Did you know, logically, that if you invoke a
Isotropy of
singularity...
space-time, homogeneity.
Can you stop now? Or I'm going to
I thought you wanted the predictions made by the Big Bang.
Those aren't predictions.
Yep.
Those are justifications for the Big Bang. Those are
I'm
things that are
actually-
invoked to justify the Big
Predictions are predictions, if confirmed, become justifications. So yes, they are justifications.
Bang.
This is just basic. This is basic philosophy
Go
of
ahead,
science.
Amy. Were you going to
If-
say something?
Well, no, I'm liking the back and forth, even when it's getting spicy, as we were saying. But just we're gonna keep on sending hearts and promoting each other talking, and I'm gonna send you right back in.
So I noticed my opponent did not want to address my question, so I will restate it. What is unscientific about an uncreated universe? Please address the question.
I already said that there isn't anything unscientific about it. I
So what is
think that
simpler? What is
most
simpler, an
cosmologists at
uncreated
the end of the day,
I want
I
to
think
know
most
what's
cosmologists
simpler.
at the end of the day would probably say that the universe is uncreated.
What's simpler, a model that accords with science we can validate here on Earth in an uncreated universe, or having to invoke magical thinking in a singularity? Which one of those is simpler?
Oh, certainly the former, which is what I'm defending.
You are defending a singularity.
No.
Do we need to go on Wikipedia to look up and confirm that I'm right and that the Big Bang does require a singularity, or are you going to grant me
it
that?
doesn't require a singularity.
It does absolutely require a singularity because the laws
when
of
you
physics
say
break
okay,
down.
I don't
That is
know.
what
I'm so
causes the
confused.
singularity.
I don't know what you. I guess I don't know what you mean when you're thinking
And
of a
you don't know
singularity.
you don't know the position you're defending then, because I literally looked this up.
Well,
on
no, I know the
Wikipedia,
position I'm
second
defending. It's the
paragraph.
concordance model.
If it invokes the Big Bang, it's invoking a singularity. That is a very
No.
high energy. Okay. See, we're not even like we're not even agreeing on basic ideas here. Does the Big Bang necessitate a singularity?
Necessitate? No.
Prove it.
Initially, because it initially predicts it because of general relativity.
It doesn't.
It's the same. It's the same.
That doesn't make any sense. How could you predict a singularity? How could you use the laws of causality to predict that causality is going to break down?
I don't know what that means. Singularities are not predicted just at the Earth. In fact, singularities weren't first predicted at the early universe. They were predicted in black holes as a result of general relativity, which when applied at a cosmological level yielded a singularity at the early universe. Well, physicists actually understanding the physics and what singularities are said, well, there isn't actually some literal physical object that we call a singularity here. What this means is that our physics, we need to improve our physics in order to understand these areas of reality and be capable of describing them. And
how about you do this?
Thus far, we don't have any adequate explanations of what goes beyond singularities. We're working on it. We've got numerous models. We've got, a big one is the holographic principle, especially in terms of ADS, CFT correspondence.
We all get it. You're
all
very
of these
smart.
things.
Congratulations. You get a gold star. You're
the
very
fact of the
smart.
matter is we don't really know how to go beyond this point. But there's nothing in the model that says
we don't
that
know.
this point must exist.
We don't know. But we know Jen's wrong. That's what we're sure about.
You want to
Actually, I don't think your fundamental premise is wrong. I agree with your fundamental premise. I just think you have a misunderstanding of what the Big Bang Theory is.
I understand it just fine, and it's clear you're making excuses here.
In what way?
The majority of your rhetoric has been giving excuses, appealing to authority.
What do you mean excuses?
Appealing to, it's not actually the beginning. It's something else. So you're saying there was a Big Bang. So what happened before it?
We don't know.
We don't know.
Well, actually, no. Inflation preceded the Big Bang. We just don't know how far inflation goes back. And part of that is because of inflation. It sort of like took all the information and threw it everywhere, and we don't really know how to find the pieces of it, put it back together to know how this occurred. We've got some pretty good ideas, primarily from particle physics, Alan Guth and the work that he's done, but we don't really know.
Right, you don't know.
Prior to 10 to the negative 32nd or 10 to the negative 36 seconds,
wouldn't it be nice
we don't know.
To know?
Oh, it would, and that's why we're working on it. That's why we're working on it. Well, no, I haven't actually mentioned Planck time myself. I did in a reference to a quote that Don Lincoln said. Well, I haven't.
Negative 32 is Planck time.
Well, no, 10 to the negative 43rd seconds is Planck time. I haven't actually mentioned that, except in a fleeting quote from Don Lincoln, who mentioned it. I don't think there isn't a reason to invoke that because we can't even get back that far. About 10 to the negative 32nd, 10 to the negative 33rd seconds is where we can go. We know that that's about where inflation ended. That's about, well, no, that's just looking at the observations that we make in everything and how it concords with our observations. That's about as far back as we can go. We know this is roughly where inflation ended. We're pretty goddamn sure that inflation happened. Then the universe slowly evolved from there. How this originated, whether it was a singularity or not, it most likely wasn't. Ask any theoretical astrophysicist or cosmologist, will tell you that there was probably not a singularity. So this idea that isn't the case. It was predicted by the equations of general relativity breaking down, but it isn't necessary to the model.
It is absolutely necessary. Anyone can look this up. You need to invoke a singularity because you need to cheat at the laws of physics. Because
why is it necessary?
Can you let me finish?
Tell me, explain why it's necessary.
You are being extremely rude to interrupt me.
Like you've let me finish.
Stop. Just stop.
So we're gonna let each person finish their statement.
It is distracting.
So Leo just finished his statement, and so we're gonna hand it over to Jen, and then we'll go back and forth.
I've lost the trail of what we're talking about. You're invoking something that wasn't there and then started to be there. You're saying,
No.
we don't know
Not
what
at all.
happens before this point. So there's no way to access what happened before the singularity.
He had mentioned inflation. Inflation happened, I think, was where he
Prior
was
to the
going with
Big
that.
Bang, yes. Inflation
Expansion,
technically
right,
precedes
so-
the Big Bang.
How do you prove that? You can't, because it's a singularity. You can't prove anything prior to a singularity.
No, there is.
You
I
keep
don't know
saying
how
there's
many
no
times I have to
singularity.
say this.
Should we pull up
There
Wikipedia to look
isn't.
up to confirm that it necessitates a singularity?
Wikipedia
It
is a source.
necessitates a singularity.
Wikipedia isn't
Why
a
else?
source.
Why do the laws? Oh, so, okay. This is ridiculous. Wikipedia is just fine for mainstream science.
No,
citations.
I'm not.
They
I
can't
did not say
correct it if they're
Wikipedia was
wrong.
inaccurate. I said it's not a source. It cites sources. It's a
Let's not
database
get
of
into
information that
Because
cites
you know
sources.
you're wrong.
but it isn't
You're
itself
talking
a
out of both
source.
sides of your mouth.
What am I
You're
wrong
talking out
on?
of both sides of your mouth. On
Can
the
you
one
tell me
hand,
what I'm wrong on?
you're saying we know all this stuff about the early stages of the universe, but we don't know anything before that, and there's absolutely no chance that these interpretations are wrong.
You're
Even though I told
literally-
you literally cannot predict blue shifting or FTL acceleration of the distant. You literally said before that the reason why there was FTL recession of distant galaxies was because they were so far away, as though distance somehow magically makes things go faster. That sounds
In an
crazy.
expanding space-time, yes, that would be true. Yes, so we've measured it.
Oh,
we
sure,
have to
you measured
actively
it.
account for it in our
And you-
equations, or they
I
don't
can
work.
account for it using simply quantum state exclusion.
I
Okay,
don't know what that
I
means.
just use the uncertainty principle to say that there's a maximum density. Do you accept that there's a maximum density of
In the
matter?
universe? Well, there's a maximum energy level, 10 to the
Doesn't
32nd.
Pauli exclusion
10 to the
principle
32nd.
predict that?
So
Doesn't the Pauli exclusion predict a maximum density per attributes of the state?
to answer your question, there is a maximum energy level in the universe.
Not a maximum density.
That
Are
would
you telling
be-
me that the Pauli exclusion principle
Are you going to
doesn't
let me
predict
answer your
maximum density?
question?
I just want to know if you're confirming that it doesn't predict that.
I'm
'cause it
trying. I'm trying to answer your question, and every time I go to answer it, you interrupt me to reiterate the same question I'm trying to answer. There is a maximum energy level in the universe that is 10 to the 32nd degrees Kelvin.
Answer the question.
10 to the 10
Don't
to the
don't
32nd.
filibuster on a question I didn't ask. Is there a
10
maximum density in the universe or not?
10 to the 32nd
so funny.
Kelvin.
Losing a debate is so funny.
we
Not taking
is
sides
there
is
what
hilarious.
what would be the maximum volume you could contain this in? I don't know if we can that.
Do you know what density
At
is?
best, the
Maximum
the
volume.
lowest
you know what
volume
density
that we could the lowest volume that we could attain would be the Planck volume. 10
Can you
to
answer
the
the
I believe
question?
it's 10 to the negative 99th meters cubed.
Simple question.
And the
Is there a
lowest mass, I
maximum
believe, is the
density
Planck
or not?
mass. I
Oh
don't
my
know
God.
how
This
much
guy's a broken
what the
record.
ratio
He's
is for
not
the
answering my question because he
smallest
doesn't actually
density.
understand
I
what
don't
it is
know
I'm
if that's
saying.
been
He's
measured.
roboting a little bit.
I'm trying to answer the question, and I'm not being allowed to.
Oh no! So we're going to give it to Leophilius so he can answer the question, and we're going to
Is
throw you
there a
right back.
maximum density? Is
Thank
there a
you
maximum
very much.
density?
Thank you very much for
That was the
reiterating
question.
that. Thank you.
Is there a maximum density? I don't think that's been defined. No, I don't think there's
Even
a
though the
Planck
Pauli
density.
exclusion
You
principle
might be
predicts
able
that there would be.
It
Let
doesn't.
Like,
him-
do you even
let him answer.
understand what a prediction is? If the Pauli exclusion principle is true, okay,
Yeah.
that means there's maximum density, okay, because it corresponds to the one where all the quantum states are filled. Do you understand that? Is that too hard for you? It does predict the
Which
maximum density
can be overcome.
per qualities of the state.
Which can be overcome. It's not really a
Oh, it
maximum.
can be overcome by what? Wishful
density.
thinking and math magic? Give me a break. It can be overcome. That's not any
No,
type of
gravity.
answer. Give me science.
Yes, by gravity.
Give me
I already
causality.
answered this question. I already
So
answered.
you're not sure
just
if there's a
repeating
maximum
things I've
density.
already
That's your answer. Your answer is you're not sure. Is that it? You're not sure.
Yeah, no,
yeah,
that's my answer. Personally,
you're not sure. Well, would you like to be sure? Because I invite you to embrace causality as fundamental to science, because then maybe you will be sure and you won't be so unsure in these debates, because it feels really good to be sure about things because you can just relax back.
I
recline on the
am
couch of
sure.
certainty. You're sure that you're
I
not
am
sure, so
sure
you don't
about
really know.
that's
You're sure
no. I
that
am
you're not
sure.
sure that there's a maximum density in the universe. Wow, that's
Holy shit! Wait, hold on.
What are you
I
sure of,
am
Leo?
sure that the
Go
Big
ahead.
Bang. I am sure that
okay.
the
You're
Big
sure.
Bang is
Oh, Big
scientific.
Bang will save me from being
As
a
I think
misfit. La, 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 la. Good job.
done
Good job. You're
a
definitely not a
substantial
midget
job
for
of
falling into the
defending.
Big Bang trap. Good job.
I don't know what that
You're
means.
saved. Just have a little bit of the Kool-Aid.
I did have a
You'll
question
be
for you though.
saved.
The Big Bang necessitates a singularity. Can you tell me what necessity is?
And that it's like part of the fundamental definition type thing, as in you
I don't
can't
know
have
what
a
that
Big
means.
Bang without a singularity. Okay, come on now. You
Yeah,
don't
but
know
if
what
it's necessary, what
you don't
when you
know,
say
okay,
that,
well,
what do
you
you
go
mean?
back to grade school and maybe learn what these individual words mean, and then you
No,
can join the debate.
I know what the word means in different contexts, and I'm trying to understand what you mean by it. Can you tell me what you mean when you say necessity? What do you mean?
Integral facet. Thing that without it wouldn't work.
So are you saying that in all possible worlds it could not fail? So if some property was necessitated in an object, it would be a property that cannot fail to obtain in that object in any possible world. That's what you're saying.
Plato. Okay, Plato. Just calm
I'm not.
down.
I don't. This is not an answer.
Assume I'm using the
You
standard
consistently
definition,
bitch
okay?
about me not answering your questions. You did not answer my question. Are you
Why are
saying
we
something
off
like
in
that?
the weeds, hair splitting about the
I am
definition
no.
of
I'm
necessary?
because
you know what
I'm
it means.
trying to show you how you're wrong.
You're trying to
do
squirm
know.
out of the
Yes,
fact
I
that
know what it
necessity
means.
is breaking the
I know
laws
what
of
it
physics.
means
Okay, I
in a
broke the
variety of
laws,
different
but I'm going to try to
contexts.
cover it up. It's
I'm
actually
trying.
causal.
I'm trying to understand what you mean by it, and you're making it very hard because you're not telling me.
Singularity is part of the definition. It's part of the definition.
So are you saying that a
part of
singular when you say it's part of the
definition.
definition, are you saying that it's analytically contained in the Big Bang? Because that would be false.
There's no Big Bang.
Because when it seems to me that you're saying that the Big Bang, it seems to me that you're saying that by the Big Bang by definition includes a singularity, which would be to say that the concept of a singularity is analytically or intrinsically contained within the Big Bang, and it's not.
I don't know if I go that far because then you're assuming
well,
it's
then
true.
The statement that you're making would be false.
Okay, let's not go into some crazy word salad that nobody.
What do you mean by word salad?
What the hell you're talking about? The question is, do you need a singularity for the Big Bang? And the answer is yes. You can look it up on Wikipedia. You
are saying
you want to say
that
no.
The concept of a singularity is analytically contained within the Big Bang, even though you just said that you wouldn't take it that far. I'm so confused.
I wouldn't uniquely attribute it to the Big Bang. You're trying to say that
what
I'm
do you mean by uniquely? I don't know what you mean when you say
only
uniquely.
the Big Bang has a singularity.
That's not at all what I.
Can we move on to something that isn't totally irrelevant to the subject?
Could be intrinsic to many things.
If you were actually scientific,
I'm just trying to understand.
You'd be laying your predictions on me. You'd be saying, "This is how it starts, and this is how you get."
I did.
Without having to invoke any magical thinking. Your whole thing is predicated on magical
thinking. I did exactly that.
Okay,
no,
well,
I don't know what that means. I don't know what that means. Oh, except for the consensus of cosmologists who would also defend the same model that I have been, the concordance model.
A less than 100-year-old model that's just propaganda. Congratulations,
what do you mean when you say it's propaganda?
As in church propaganda. You're unfamiliar with
by
this
what
concept,
church? The Lambda CDM model was developed by
Are
secular
you aware
scientists.
of the fact that Christianity was forced onto Europeans under threat of death and persecuted them for hundreds of years? Are you aware
this
of that?
isn't a debate. This is not a debate about antiquities. This is not a debate about history.
Where ideas arise from matters.
Moderators.
Why did nobody have any idea of the Big Bang prior to 1932? How come nobody thought about it? Were they just so dumb before 1932 they never thought of it?
I mean, they kind of had that idea in 1927 when Edwin Hubble originally made his observation of the expansion of space-time. What took him so long? We didn't have the technology prior to that to make those observations. And then when we got the technology, an observation was made that was very weird and that did not fit in with what we currently understood, and that was that. I'm sorry.
get
Sorry.
a model that matches
Sorry.
the Bible and cosmological
Excuse me.
creationism.
All right.
Excuse me, I was
All right.
speaking.
You were
Let him
filibustering?
finish.
Yeah, I know.
Excuse
I was
me.
tired of you
Excuse me.
talking over me the entire time.
Excuse
You
me.
need to
Well,
keep your
guys,
comments a little
guys.
shorter.
Hello?
Yeah.
I'm gonna
Hello?
filibuster
Can
both.
can you stop filibustering,
Hello?
please? Hello?
Mute him, Amy. Mute
And
him.
well, no. So
No.
I'm trying to remember who was the last one talking.
I was
Leo
trying
was
to
trying to
explain
answer a
something.
question, but I think
Leo
she thought it was going on for a while.
Is
but
so
we'll let him
Leo's
finish.
And it
going
wasn't.
to finish his statement, and then we're going to
Right.
hand it back to Jen because we heart both of you. So Leo, floor is yours.
So we didn't. There was a point where we didn't have the technology to really peer out into the universe beyond some arbitrary point, which wasn't really far beyond our galaxy. And once we got that capability, we could look quite far. We could look, well, quite frankly, tens of millions of light years and pushing hundreds of millions of light years. And it wasn't until we could do that the observations made that, hey, we look out and the further we go, the redder galaxies get. Well, if their redness is proportionate to their distance, and I already said this, but if their redness is proportionate to their distance, that doesn't mean that the galaxies are moving away from us. That means that the distance between us and the galaxies is growing. The more space you have between us and the galaxies, the more space there is to expand, and the faster that it will expand. I think I have something that. Give me a second here. I think. I don't know if I've still got it up there. But I have a rubber band with lines drawn on it. That if I pull the rubber band apart, the lines that are furthest away will move away from each other faster than the lines that are closer together. The reason for that is there's more rubber band between them to be stretched, so they will stretch more. It's the same with space-time. We've observed this. Go to any institution on the face of this planet and ask anybody with a degree in this, and they'll tell you, oh, absolutely, space-time is expanding, and galactic redshift was the primary observation of this that has been confirmed time and again with the Hubble Space Telescope and every other space telescope that we've put up.
Let's hear what
This is
Entropy has
supposed
to
to be
say
a
about it.
conversation. This is supposed to be a back and forth, not a
Yes,
random
now you have
and then
roughly 2
accusing
minutes
me.
to make a statement.
All right, go ahead, Jen.
It was supposed to be a back and forth, so I'm ready for a back and forth. So if you could clip your little
Go ahead.
rambles of word salad and
Go
not
ahead.
cut
Why
me
are
off.
you not
Not
rebutting?
cut me off, including this. Don't cut me off.
You're
now.
complaining about
Just
rebutting,
stop.
but you're not
All right,
rebutting.
let her
Can you
go. Let her
stop?
go.
Just
Let her
stop.
go.
So we didn't know, even though the ancient Vedics knew all sorts of cosmology and the Christians had to go begging them for answers back in the day in their quote unquote golden age, miraculously now we have some random experiments and we can instantiate the exact same metaphysics as the Bible. And that's not at all a coincidence. So here's what I want to know. How does the Big Bang predict that all the planets in our solar system are going to be dated to the same age? How does something even come to have an age? Why isn't everything just the same age as the universe?
The Big Bang model is a model
Can
in
you
early
answer
universe
the question, please,
cosmology.
without launching into some excuses about the Big
If
Bang being shit?
if
We
I
know
weren't-
it's shit. That's what I'm proving right now.
Aren't being interrupted consistently, I would probably have a much easier time.
It would be nice if you could just answer
your
the question.
questions.
Could you just answer the
I
question
can't
as I
answer the
pose it?
questions
All
when
right,
somebody
guys.
is consistently over talking me every time I try to answer their questions. I can't speak for 5 seconds without you interrupting me. You really expect somebody to answer a question in that amount of time?
I don't
Okay,
expect you to answer
so
the
then
question I
don't
asked,
even
which is
remember
why I
your
said,
question.
please answer the question I
don't even
asked.
remember your question, right? Because I had to explain why I can't answer your question.
Right, because you had to
interrupt me every
filibuster
time I
because
answer
you don't know
your
what you're
question.
talking about
So
and you
if you
don't want
would-
to answer it.
If you would kindly
I will,
reiterate the question
I will
so that I may
restate it. Yeah,
answer.
sure, because I'm real curious. Why is it that...
Oh, I
Okay,
remember
tell
your
me how
question.
you're...
It's about
Okay, go ahead.
predicting the formation of planets and stars. The Big Bang model is a model in early universe cosmology. That this is not a model that applies to the scale of planets and stars. It doesn't need to make predictions. It's like saying, oh, well, you know what? Economics can't tell me about plate tectonics. It's not designed to. That's not what it's designed to explain. So that's why it doesn't make predictions about it. This is not about how planets and stars form. We would look to, the physics on the interstellar medium, stellar astrophysics, planetary physics, planetary science. A very good friend of mine, Orge, is in the side chat. He's a geophysicist. He can tell you all about this, and I'm sure he'd love to. But this isn't cosmology. We're not talking about cosmology at that level.
The
And with
age
the
of
Big
the
Bang, we're
planets
dealing
and
with
sun isn't
cosmology.
cosmology? Is that what you're saying?
The age of the planets? No, that's
That's
not
not cosmology. The age of
Planetary
planets.
science is not cosmology.
Planets, the age of suns, that's not cosmology.
Well, their ages are on cosmological scales, but the
But it's not
cosmology.
cosmology.
Cosmology is a subject of study. It doesn't study individual stars and planets. It studies extragalactic structures, general relativity and electromagnetism at the extragalactic scale, early universe physics, things of that nature. That's what cosmology deals with. If you don't believe me, I would be glad to cite from actual universities on this.
Well, I have an issue here with there existing different ages in the universe that we can infer through emission spectroscopy, yet the Big Bang seems to suggest that there was a beginning, so shouldn't all matter be the exact same age in the universe? And if not, what accounts for the different ages? Because I'd love to know.
From physics.harvard.edu on their course Physics 212 Cosmology, taught by Cora Dvorkin. If you don't know her, she's renowned in the field. Standard cosmological model and inflation, scalar inflationary models, cosmological perturbation theory, brief introduction to quantum fields on cosmological backgrounds, interactions in Keldysh-Schwinger perturbation theory, non-Gaussianities, symmetries, and cosmological word identities. I didn't hear anything about stellar formation and planetary formation, but I bet if I went to the planetary physics in geology and geophysics, I would find a lot about that, because that's the field that deals with that. Cosmology, and thusly the Big Bang, don't deal with how stars and planets form.
Okay, right. So cosmology has nothing to do with cosmology, because Big Bang
I don't know what that means.
Can't predict different ages of the universe. But it's somehow the answer we've all been looking for, even though all it does is turn us into rambling people who have nothing but excuses and word salad. And well, we don't know that
find the best ways
the
to
ages of
substantiate my
stars is not cosmology. Would you believe someone that told you the ages
no.
of stars wasn't cosmology? You'd be like, what? Because I'm definitely kind of like, what? I'm confused.
Can I make one last statement, and then we're free to move into closing statements after that? Does that sparkle with everybody?
Sounds good.
So 8.942 Cosmology at MIT, Thermal Backgrounds in Space, Cosmological Principle and its Consequences, Newtonian Cosmology and Types of Universes, Survey of Relativistic Cosmology, Horizons, Overview of Evolution in Cosmology, Radiation and Element Synthesis, Physical Models of the Early Stages, Formation of Large-Scale Structure to Variability of Physical Laws, First and Last States, Some Knowledge of Relativity Expected, 8.962, which I believe is General Relativity, Recommended though not required. Nothing about how stars and planets form and how galaxies form, because that's not cosmology. That would be astrophysics.
Well, no wonder I dropped that class.
Did you get your degree from MIT?
They don't really seem like they know much.
No, I like legitimate, like genuinely serious question.
Legitimate, I think we're done and we're going into questions.
Did you get your degree from MIT? I'm actually curious.
Well, the Q&A section is gonna be right next after we move into closing statements. In fact, that's gonna bring us to the end of our open discussion. We hope you found valuable information from both of our interlocutors. You can also find both of their channels as links in the description below, though we're now going to hand it over to them again for their 5-minute closing statements. We'll then finish off the night with some Q&A. And if you have a question for either or both of our debaters, feel free to tag me in chat at Amy Newman. Thank you both again for being here tonight, and I'm handing it back over to you, Leophilius, to start our closing statements.
Yes, so the Big Bang model makes a number of predictions. It predicts that the universe would be expanding on the average over its history, an observation that has been made and confirmed throughout the history of cosmology. It predicts that there would be a background radiation permeating the whole of space-time that would be near uniform in both its distribution and its temperature as a result of electromagnetic radiation decoupling from matter, the period of recombination, as it's often referred to as, that occurred some 379,000 years after t equals 0, if we're using that as our arbitrary starting point. And we've observed that and have measured it to greater accuracy with WMAP and then the Planck survey, all of those things. And it is a uniform black body radiation, which means that we know how it arose It's not emitted from stars or galaxies or anything like that. It doesn't come from those sorts of processes. It is a uniform distribution of a thermal black body radiation, and that is powerful. Like I said, the cosmic microwave background is what does it. That is effectively proof that the universe originated in a very hot, very dense state. But it also predicts an abundance of hydrogen, and the universe is still, if I'm correct, somebody in the audience, immutable, look it up, figure out if I'm correct, Atheist Junior, somebody. I think that the universe is still something like 70% hydrogen in terms of its baryonic mass. Oh, and the abundance of hydrogen in the very, very early universe after primordial nucleosynthesis, it would have been something like 98 to 99% hydrogen with a very, very small amount of helium and an even smaller amount of lithium. The abundance of hydrogen was predicted by the Big Bang model. It also comports with general relativity. It comports with things like aspects of special relativity. So it comports with numerous aspects of the large-scale structure of reality of the universe. So the Big Bang certainly makes predictions. It was a model that was proposed based on preliminary observations that were made. The predictions were derived from it. Well, if this full model is true, these are things that we should see. All of the things that it said that we should see, we do see. The homogeneity and isotropy of the universe is another one. If you look out into the universe, it's going to look the same in regardless of which direction you look in, and no matter where you go anywhere in the universe, it's going to look the same regardless of where you're at in the universe, the isotropy and homogeneity of the universe. Another thing that was predicted by the Big Bang. Now, it did have some problems which were swiftly resolved by inflationary theory, which has been incorporated into what is now called the lambda CDM model. Again, lambda representing the cosmological constant, which is no longer a fudge factor. It's something that represents a very real and observed aspect of reality, the accelerated expansion of space-time. And CDM, again, represents cold, dark matter, an observed and not very well understood aspect of reality. On top of the Big Bang, on top of inflation, formed the concordance model. This is the model that if you went to any institution, like two of the most prestigious institutions for physics and cosmology that I cited, Harvard and the Massachusetts Institute of Technology, this is what they'll tell you. This is what the model describes. This is how it's been confirmed. This is why it is used. And people who want to appeal to a significantly smaller scale and physics as they behave on that scale to try to refute the Big Bang are bound to fail every time.
Woohoo! Thank you so very much, Leophilius, for your closing statement. And with that, we're going to hand it over to Church of Entropy for her closing statement.
Great. So if you could just share my screen, Amy, that'd be awesome. I just want to put up my diagram there again. So we've heard a lot of excuses, rationalizations, justifications, very complicated stuff. Constant assertions that the Big Bang predicts these things, and you got to be clear what it means to when you say predict. You have to show a clear chain of causality from one to the other. But if your whole thing's hinging on causality breaking down, you're on really shaky ground. It's just not scientific by the very definition that science describes the causal undergoings of the universe. So just to address these points, I think that it's pretty clear that all this stuff is justified post hoc. At what point did anyone go back and consider that maybe the Big Bang never happened and it was an uncreated universe, and really give that a chance to predict what you observe and hopefully make novel predictions? That hasn't been done because there's a vested interest in the Big Bang being the accepted cosmology, possibly because it accords largely with the creationism present in religious texts, possibly other reasons due to the sunk cost fallacy. I'm not sure, but I feel strongly that it's not really giving people much insight into what's really going on. It's not intuitive. It's something you have to keep repeating because it's impossible to internalize or memorize the notion that everything that's out there, and not just what we can see, but what we can't see, was contained to one single soup way back in the day. If you think of it alternatively as just simply, it's always essentially been more or less like it is now, and there's a pump, i.e. a way for it to expand and a way for it to contract. And space-time is instantiated in that pump. So an instance of space-time being instantiated would be like a star being excluded from a super dense region. So Leo wanted to deny that A maximum density exists when it seems to be a prediction of the Pauli exclusion principle, at least per state variables, as we would understand them in the familiar thermodynamics. Per set of state variables, you have a unique maximum density state above which additional matter entering that state would be excluded by the Pauli exclusion principle. So that's just what's happening in dark matter, which is the black parts of the universe, the high mass parts, the parts they allegedly can't understand what it is, and somehow it's exactly the same as the CMB. You don't need to invoke all that. Just understand that space-time is created when there are these exclusion events. It starts the clock. He can't answer why the clock gets started, why stars have different ages. He really fumbled that. I think he was unable to link it, and he had to launch into a filibuster about why actually cosmology doesn't deal with cosmology. So we look at this model, it's very simple. You have matter impeding to the maximum density state. Why? Because of gravity, but there's a limit to how much gravity can compress, and we can see that evidence of that everywhere. The bigger the star, the more diffuse it is, right? Because in its center of mass, you can't manifest uncertainty effects without it starting to break apart. You can look at Hawking radiation. I'm not the only one to posit a model like this. It's very simple. You have this additive sequential exclusion in a dark mass region, in a high density region, i.e. the center of the galaxy, which I predicted would precipitate new stars and was indeed observed in 2017, unprecedentedly observed. So people who claim my model doesn't make predictions are simply confused or just lying to you. So it's very clear that newly created matter, that's where the clock starts. So the clock starts a bunch of times, every time there's an exclusion event, and each time there's velocity that's instantiated, and those velocities are added up over long distances. That's why we can have faster than light recession, because it's not accelerated. That's what the law is saying. You can't accelerate mass to the speed of light, but it wasn't accelerated in the first place. It was excluded. So we can have what I'm calling temporal lensing, whereas you're looking through all these bubbles of space-time that have been sequentially created and seeing the combined effects of all of their velocities adding up to a really big velocity. And that's how this model actually predicts that the farther away you go, you don't have to invoke this magical thinking about strings stretching and all this other counterintuitive stuff. Just understand that causality and temporality are different things. The quality of having time is not the same as causality, okay? Temporality arises from causality. Causality is more fundamental than temporality, because temporality doesn't exist in the dark matter. It only begins to exist when the matter's excluded, forms a star, and then it starts to age ever so slowly. And that's what we're inferring the age from by looking at the emitted distribution of elements to say, okay, well, there's been some decay in those elements corresponding to this amount of time based on previously known half-lives of the constituent elements. So hope you'll consider an uncreated universe, which is cyclic and more or less always the same, and the cosmic microwave background simply being an effect of mass interacting with itself. So it's not going to go all the way to the limit because it's not dense enough. The exclusion of stars is only in the very maximum density regions, but in the non-maximum density regions, they can still precipitate centers of mass because gravity assimilates, but it quickly dissolves, and that's where you're getting these escaping photons from uncertainty effects. Just have to remember what it is the uncertainty principle is really saying. If delta X is really small, i.e. the physical separation between two massive waveform energetic centers is sufficiently small, that just the universe just creates a massive difference in their momentum. So there'll be a separation of momentum, which means one will be relatively larger and can break apart at that point. So you have a mechanism for compression and expansion. Don't need to go further than that. Don't need to invoke magical thinking with the Big Bang. And I think this model will stand the test of time, unlike the extremely young Big Bang, which, as I've said, and hopefully convinced you here today, is not scientific. Thank you so much. And I hope that was 5 minutes. I feel like I've been blabbing for a while. Is it? Okay. Amy's nodding there. Okay, good. Thank you.
And okay, with that, thank you both. Thank you so very much, Church of Entropy, for your closing statement. We are now going to move into our Q&A section. We currently have a bunch of questions, so thank you guys for sending them in. we're a little lopsided with questions for Church of Entropy. So if you have any questions for Leophilius, now is the time, and feel free to tag me in chat at Amy Newman. But all right. Mark Reed says, if the Big Bang model was not scientific, how did it predict cosmic background radiation before it was found?
I'm not sure if that's a fact. So you'd have to point me to where exactly it says that, because that's a really
The links
specific
I put in the
prediction.
chat say that.
Not a very okay. And when did this happen? Because I'm not sure I buy that.
One of them is from the Stephen Hawking Center for Theoretical Cosmology at the University of Cambridge. If anybody's interested, I think it's the most recent link that I've provided. You can take a look there.
And then we're just going to let Jen have the final word, and then we're moving on. Or is that me?
Oh, well, like I said, you're going to be presupposing more than the Christians if you want to make that prediction. So thanks for the anecdote. I don't really think it proves anything.
Okay, I have a question. Does it give Church of Entropy any pause that her ideas generally do not agree with the majority opinion in the relevant fields?
No. Does it give you pause that you can't understand that my theory is scientific, yet you supposedly understand science? Consider maybe you're actually not understanding science and that you've been brainwashed.
Mm-hmm. For Church of Entropy, assuming Big Bang is not scientific, what explains its prevalence in the current? Oh, that's kind of similar. Current discourse among scientists. So
I'd be speculating, right? But I think you really have to look at the cultural situation that it arose in, right? Like ideas do not arise in a vacuum, and we can get a lot of insight, but we can't necessarily jump to a conclusion as to why. There probably isn't just one reason, but a lot of it you're looking at sunk cost fallacy, as well as ideological convergence, because you can look this up. The Catholics took this as a major win for their religion when it came out. As much as people want to deny that, it was basically just a way to substantiate the Catholic metaphysics, biblical metaphysics of creationism ex nihilo.
woohoo! And moving right along, question for Leophilius. What, in your opinion, are the weak points of Big Bang Theory?
It would depend. Are we talking about just the Big Bang Theory on its own? I would say the monopole problem, the horizon problem, and the flatness problem are some big ones. There are certain discrepancies between the smaller scale and large scale structure in the universe, but all of these are explained by inflation. So again, I would just turn to what is referred to as the concordance model in the standard model of cosmology, which incorporates much. It's the Big Bang beefed up with much more observations and much more data that we've collected since the Big Bang was originally formulated roughly 80 years ago.
Woohoo! All right, moving right along. I'm going to put this in the form of a question. Is she invoking the PSR, which AFAC is still debated both philosophically and scientifically?
What's PSR?
Principle of sufficient reason. It states that everything has to have some sort of reason or explanation for its existence or cause or what have you.
I'm going based on what I understand to be the soul or essence of the Occidental scientific method, which is predictive, bottom-up metaphysics, which obeys the Occam's razor principle. And I have certainly met that. But due to the massive lack of understanding of what science actually is, people have trouble accepting it and think that the fact that I put a parody comic in a scientific explanation publication on my own blog somehow disqualifies it. You have to learn to judge the ideas on their own merits. Ignore the noise. I think you're muted, Amy.
You're muted.
Oh, I do that sometimes.
She loves that
Something
double
from
tap.
nothing Has to double tap. Remember, folks, when it comes to zombies, always double tap. At what point will Leo blow her mind with facts questions for both?
A singularity of facts, you might say.
No comment.
Moving right along. Has Church of Entropy's model made any traction in astrophysics academia as to earn a Nobel Prize or some other accolade?
I can give a link that shows a prediction I made that wasn't validated until after
I don't know if you want to
made
send
it.
that to the chat, Amy.
Yep, and put that in chat, and then I'll just link it
yeah,
right in the
there it
other
is.
chat. Oh,
So
sounds good.
understanding how things works is it's not just about having good instrumentation. It's about how you're understanding things, aka metaphysics. So if you're not looking in the right place, you're not going to find the right answers, and that's why this wasn't realized until very recently, because someone had to come in and give them a bit of a smack in the head and say, "Hey, go over here now. You'll find what you're looking for."
So maybe
how
the Nobel
stars
Prize
can
is in the
form.
mail. It's on the way. It's coming.
So it's just a really blue-pilled thing to say.
There you go.
Jake 4D. At Amy Newman, answer for Leophilius. 73% of the mass visible in the universe is hydrogen, 25% helium, and everything else is the remaining 2%.
Okay, so yeah, I'll take that as confirmation that I was accurate when I said roughly 70% of the universe in baryonic mass is still hydrogen. Yeah, and which is thoroughly explained by the Big Bang. The thing is, all of the individual predictions that the Big Bang makes, it making them all at the same time, cannot all be made at the same time by any other model that's ever been tested by any cosmologist anywhere at any time. So that's why this is the model that most cosmologists accept, because all of the observations that we make are explained by this one thing, that the universe originated. I shouldn't say originated, that very early in the universe, it was in a hot, dense state, and through the expansion of space-time, generally seen as a result of inflation, it expanded and cooled and evolved through entropic processes into what we see and what we are today.
Woohoo! Question from Danny. Church of Entropy, do you distinguish natural history and science?
I don't know what kind of a question that is. I mean,
It's a very interesting question.
There we go. And moving right along, very serious question from Bob Sadler. Is Leo single and willing to go out with the same sex? Hot topic tonight.
I am single, and unfortunately, no, I am a cisgender heterosexual male, but I am certainly a straight ally.
Woohoo! And all right, from Mark Reed, Jen, what experimental data do you have to demonstrate that your model has made testable predictions better than the Big Bang Theory?
like I said, I just put that link in the chat. I think the most important prediction is that my model, the mechanism of my model, predicts that the farther something is away, the faster its velocity will be observed to be, because each of these stars are created with their own individual velocities, which are added across distances. I think that's pretty good. An uncreated universe. I'm just going back to the standard, what everyone always believed for all time until the advent of Christianity, whereas Leophilius is defending essentially a biblical metaphysics. I'll just remind everyone of that again. Unprecedented until that point. So you're banking on that stuff being true.
Woohoo! And all right, I'm going to say we're going to take in a few more questions. We're having fun.
I'm a naturalist defending a Christian worldview. Hey, I'm on your side, Otangelo. I bet he'll disagree, though.
Question from Jake 4D again. For Leo, would you agree that a better name for the Big Bang would be the Great Stretch or something like that?
Yeah, I often, like, when I am in a discussion with individuals in certain contexts, I'll say it's not really the Big Bang Theory anymore. It's the Lambda CDM model, or the standard model of cosmology.
Okay, and moving right along. Let's see. Has the model that from Bob Sadler, has the model that Church of Entropy is presenting been peer reviewed? And if it has, what have those peers said?
I don't have any peers. The peer review is another one of those things. It's not really scientific at all, but we'll go into that another day.
Here we go. Question from Immutable Destiny for Leo. To what process can we attribute minor variations in, is that entropy? I'm not sure if I'm spelling it wrong. He is in the CMB.
How spell the word for me?
anisotropy.
Oh, anisotropy. Or anisotropy, however you choose to pronounce it. Okay, so I'm sorry, read the question again.
For Leo, to what process can we attribute minor variations, or that word in CMB?
Anisotropies. So what accounts for why there are anisotropies in the CMB? Quantum fluctuations in the early universe. Essentially, quantum fluctuations in the inflaton field that, as it decayed and space-time stretched, would have been transferred into space-time, and we would see those in the CMB as minor variations in its temperature corresponding to denser and less dense regions in space-time.
And the thing is, the wave function.
The CMB does match with, like, as best as we can measure, the matter distribution in the universe, indicating that the CMB is literally an imprint of the very early universe, which is exactly what it is. That's also why it's very heavily studied in early universe cosmology.
Question from Mark Reed. Do you think your objections are valid when they rely on logical fallacies like the argument from incredulity and argument from ignorance? Uh-oh, shots fired.
Well, I mean, you got to sort of be more skeptical about accepting these, quote, logical fallacies at face value, right? Like, you don't want to go full J. Dwyer where it's like, well, you made a logical fallacy, therefore your entire position is invalidated. It's like, well, then what are you going to do next? Like, jump on why something isn't actually a logical fallacy, like appeal to authority, etc. It's like, okay, argument for incredulity. If I can't understand something quickly, and I'm super smart, what are the chances the average schlub's going to be able to understand it? And if the average schlub can't understand it, then what's the point? I think if it's going to be useful, it's going to be accessible to everyone to some extent. And these singularities, magical thinking, unscientific things, they stun your mind. They paralyze you, and you can't think past it, and you become rigid and stuck. And it's very hard to see when a superior scientific model is staring you right in the face with all the answers, because you've been sort of affected by this belief. So science is extremely powerful, but has to be used correctly. It's not like the incorrect appeal to authority is the appeal to the quote unquote scientific consensus, which is being invoked, frankly, in these streams, not just this one, way more times than it should, because frankly, you're arguing for a consensus where it's very misleading to imply that there even is a consensus in a lot of these domains. And so there is something to be said for how well a model could be understood, because we have to be able to remember it for it to mean something to us, to be able to be carried forward. If you care about that kind of thing, like your model being relevant in 100,000, 10,000 years, which clearly some people are more interested in intellectual masturbation than that. And those won't stand the test of time. They're too complicated, not really what happened, and have alternatives that are much simpler and accord with the least action principle. Thank you.
That caught Amy's attention.
Mm-hmm. Question for both Brian Stevens, to both debaters. Big Bang equal the square root of -1. Agree or disagree?
Well, I think it's a troll question, so no, I don't think that's true. Look, Leo and I agree on something, finally. High five.
I think we also agree that the universe is an uncaused or uncreated thing.
That's actually
a few
cool.
points of agreement, yeah.
But we love you, Brian. Steven, send in love. In fact, to all our viewers and watchers and the people sending questions, we're going to do a few more, and then we are wrapping up tonight's episode of Debate Me Brah. Is the Big Bang scientific? Jason wants to know, what are your Jen, what are your credentials? What is your highest degree, major,
Here we
area,
go.
institution? You do not have to answer. I'm just
Oh,
gonna
I don't mind. I don't mind at all. I got a honors degree in physics math from Auto U, cum laude. And then I worked for the audio video analysis unit doing applied science in signals processing, AI, automatic speaker recognition, image comparison, and I could go on for a while.
That's
so
all based as fuck. I'm just gonna be honest. That is all based as fuck.
I really loved my other job, which was interpreting for deaf people in university, and I got to go and basically proctor a bunch of classes. So I didn't actually have to do any of the work, but I just had to show up with a deaf client and type on my computer what the prof was saying. So I got to like sort of absorb by osmosis all these different things. And my general approach to this is that I want people to understand why you need God in order to ground your thinking, and the fact that I was able to come up with this model that's more correct than all my competitors is intended as the proof, and sort of the basis of that is the quantum periodic table. I don't know if everyone's seen it, but the things I've done in the studies I've taken really don't fully inform my motives. I'm at the heart, fundamentally, I really want to teach to as wide of an audience as possible and give them an appreciation for physics that I've got to enjoy for all this time. Thanks.
Poggers.
Mm-hmm. And all right, question for Leophilius from Apricot Sloth. Are there any alternative models to the Big Bang that you know of that are common in discourse among scientists?
Models
Is
that
that
replace the Big Bang? No. Models that take the Big Bang beyond where it currently is? Absolutely. I mentioned ADS CFT correspondence, which is a correspondence between an anti-de Sitter space and a conformal field theory defined on that space. And it's what's called a gauge gravity duality, which is not something that's really important to understand what it is. This is a fancy title. It's a quantum theory of gravity. It incorporates the holographic principle. You've got loop quantum gravity, string theory, superstring theory, and theory. There's quite a few that take the Big Bang beyond relativity. I mean, you got the Aguirre-Groton model, the Carol Chen model. There's a lot of different chaotic eternal inflation by, I think, Alan Guth. There's the ekpyrotic models by Steinhardt, I think, conformal cyclic cosmology by Roger Penrose. I mean, there's a lot of models that take the Big Bang beyond where it's gone. But the idea that our universe, at least as we see it and understand it and observe it from where we're at, that it started earlier, from our perspective, earlier in its evolution, it was in a very hot, very dense state, is something that I don't think any respected professional cosmologist, or that anybody that really understands the field would be willing to deny.
Mm-hmm. All right, moving along. I'm going to paraphrase this, but from Gonna Go For It,
Oh boy.
Peter wants to tell you, Leo, that he thought you did a fantastic job, so he's sending you love there.
Thank you much, Peter. You know I love you, buddy.
Question from Ogre, Church of Entropy. Could you detail why gravity cannot break PEP or PEP?
Well, how do you prove any law? It can't be done. Science can only disprove things. And then you can talk about standards of proof when making subjective judgments. But my best evidence in support of the position that PUP can't be violated is the fact that it's instantiated in multiple domains. So you can frame what's happening in the slit experiment with the electron as this type of effect. You have chemistry operating on this principle, and you also have some people, aka Hawking radiation, operating on a similar principle. Like he's arguing that it is the uncertainty effect, but if you think about it, the fact of two things being brought into close proximity causing a delta in their momentum, and the fact that two massive waveforms can't occupy the same quantum state, maybe that's kind of the same fundamental thing happening, which is just what, like I said earlier, this idea of a maximum density, so that being something that is intrinsic to a particular phase space. So you can't prove these laws. You just have to go based on statistical analysis. Where do they instantiate a whole bunch of times to the point where it's like, okay, there's so much evidence in support of this. Can I find anything that suggests it can be violated? You look around, no, except for this Big Bang malarkey, and you conclude, yes, it's a law. Same with gravity. It's like, well, could there be an anti-gravity space? Well, theoretically, there's nothing precluding it from an absolutely naive first pass, but we have no reason to believe that because all the evidence accords with it. Same idea with Pauli exclusion principle. Thanks, that was a good question.
Woohoo! All
That was
right,
a good
we're
question,
almost out of questions. We got a few more. Leo, I think this is a more tongue-in-cheek. He says, "Are you an average lub?" This is from E343. I guess
You got muted, Leo?
Am I an average what?
Lub.
average lub. That tends to be the
L-U-B.
Yiddish that we use.
Well, Jen said the average lub should be able to
No,
understand
I said
the theory.
schlub. I said
okay.
schlub like
It's
in a
Yiddish.
loving way, because I want it to be like schlub-friendly science so that everyone can appreciate it, kind of like a big
There you
hug
go.
box.
So, am I the average schlub? I would say no.
No, you're
There you
very
go.
intelligent.
Heard it
It's
first.
clear. It's clear you have a good head on your shoulders.
Well, I don't have the credentials that you do, so that's a,
Well, I'm sure one day you'll be a big star.
oh hell, it would be nice.
Well, Leo, we're gonna put that to
Go
the challenge.
backstage
The
with
question.
Nickelback one day. Goals in life, Leo. Goals.
No, Nickelback's going to be trying to get backstage with him. You got it all backwards.
There you go.
See? What observations would disprove the Big Bang?
Space-time not expanding, either contracting on the average over its history or being static on the average over its history. Hydrogen not being an abundant element, and it's not that any one of these alone might, but some of them might alone. Some of them you might have to take with other things. There being no background radiation, the cosmic microwave background radiation wasn't a thing. That would also do it. The expansion of space-time. I think I might have already mentioned that. If space-time isn't expanding, obviously that wouldn't. So there are a lot of ways you could falsify the Big Bang. It's just that the Big Bang hasn't been falsified because it's past every empirical test that it's been put to. Well, I should say the concordance model has passed, at least currently, almost nearly every test that it's been thrown at. There's a few where we're like, yeah, we don't have the full suite of data on this, but for the most part, yes. There's no reason to call it into question, I think, is what most professionals would say.
All right. We got 4 questions left. I'm going to do the 2 palate cleansers, and then I'll give you Don Wills wants to go. I'm going to rephrase this. Pajamas or none? You don't have to answer. D. Willis, hard or soft taco?
Soft taco, corn tortilla, homemade, with like tongue meat or cheek meat or something like that. And I'm talking like traditional Mexican taco, like that. That is a taco. That is what a taco is. That is what a taco should be. If you've never had one, find somebody who sells them and eat one. You will love it.
So check out Leo at Taco Bell. What about you, Jen?
Oh, fuck taco. Oh,
I would say crispy. I like crispy. I can't go into as much detail because I don't have as evolved of a palate there. I like the crispy, and I like to sleep with PJs.
There we go. Ladies and gentlemen, we're answering the questions that really matter tonight. And all right, Jake 4D for Church of Entropy. This was a little unclear. Are you a theist?
Yes.
There you go. And then the final question of tonight from
Pantheist specifically.
on
though.
Tangelo's
yeah.
blog. Amy Newman, ask Leo how many cosmological parameters define the Big Bang?
I don't know what he means when he says that. There aren't any cosmological. Well, yeah, I would need to know what he means when he says cosmological parameters that define the Big Bang. I don't know what to make of that.
And there we go. That is the conclusion to this episode of Debate Me Brah. Woohoo! Is the Big Bang scientific? We hope you had a fantastic time with tonight's debate. I want to thank my co-host, James W., along with our debaters, Leophilius and Church of Entropy. Absolutely. You can find both of our interlocutors' channels in the description below. If you're feeling fancy, remember to like, follow, and subscribe. And if you'd like to support the show, feel free to check out our Patreon at Patreon.
There's going to be a post show on my channel, and I don't have a link for it ready yet. I've got them permanently now. They're always within arm's reach now. So if anyone wants to check out the post show, I will have a link, and you can join. So everyone's welcome to join on that, as long as you're not going to try to torpedo the stream.
Amy,
that's right. So go check out
subscribers. Congratulations.
Thank you so very much.
Leo.
I know we're throwing fireworks. And thank you to all our viewers and subscribers for making this possible. And don't forget, like Jen said, she's going to be running an after show at her channel. So feel free to check that out. And I think
can I make one last statement
below?
Really, very quick.
Go ahead.
Sort of not related to the debate.
While they're dancing.
For Otangelo, I'm sorry, and we both know this. You have no idea what any of the things that you just cited means. There's no reason to engage with you. Anyway, thank you, Amy. Thank you.
And
thank
we
you,
are all
Jen.
Switzerland, but I will say on Tangelo, you just heard the gauntlet thrown down. So I think what we need to do really is have Debate Me Brah on Tangelo versus Leophilius.
A fourth time? Maybe.
And all right, like I said, if you'd like to support the show,
physics lesson from Otangelo. Always fun.
Check out our Patreon at patreon.com/Amy Newman. I'm Amy Newman, and we also hope you have a great time on the next adventure of Skeptic Ball Z. Good night, everyone.
Good night.
Bye.
Bye.